Good morning, dear students. Today we will learn some problems on complex numbers. In previous class, we learned about complex numbers, introduction, properties, formulas, and some problems. And now we will see some more problems. So, objectives. On completion of this period, you would be able to define conjugate of a complex number, write modulus, amplitude, we can say polar form of a complex number, state properties of conjugate, modulus, and arguments. Solve problems on various properties. Recap. We know that an expression of the form x plus iy, where x and y are real numbers and I equals to under root of -1, is called a complex number. Additive inverse of x plus iy is minus x minus iy. If z equals to x comma y is a complex number, then multiplicative inverse of x plus iy is x minus iy by x square plus y square. Conjugate complex numbers. If the sum and product of two complex numbers is a real number, then they are said to be conjugate to each other. If z equals to x plus iy, then the complex number x minus iy is called conjugate of the complex number z and is denoted by z bar. Thus, if z equals to x plus iy, then z bar equals to x minus iy. Note: two complex numbers which differ in the sign of their imaginary parts only are called conjugate complex numbers. Properties of conjugate of a complex number. For any complex numbers z1, z2, z3, we have z1 equals to z2, that implies z1 bar equals to z2 bar. Second, z bar and bar, that is double bar, equals to z. That means conjugates of the conjugate. Third, z plus z bar equals to 2 into real part of z. Fourth, z minus z bar equals to 2i into imaginary part of z. Fifth one, z1 plus z2 bar equals to z1 bar plus z2 bar. And sixth one, z1 minus z2 bar equals to z1 bar minus z2 bar. Next, seventh one, z1 into z2 bar equals to z1 bar into z2 bar. Eighth one, z1 by z2 whole bar equals to z1 bar by z2 bar. Next, modulus amplitude and modulus amplitude polar form of a complex number. Let z equals to x plus iy be any complex number. Put x equals to r into cos theta and y equals to r into sin theta. Squaring and adding 1 and 2, we get x square plus y square equals to r square, that is r equals to under root of x square plus y square. Here sin square theta plus cos square theta will become 1. Equation 2 plus equation 2 divided by equation 1 gives y by x tan theta, and then theta equals to tan inverse of y by x, and that implies z equals to x plus iy, that equals to r of cos theta plus I sin theta. Thus every complex number x plus iy can always be expressed in the form r of cos theta plus I sin theta. See here, the number is expressed in the form of angles. So cos theta plus I sin theta. So theta means it is an angle. So very interesting this. The complex number x plus iy is called the Cartesian form of z. R of cos theta plus I sin theta is called modulus amplitude, that is polar form of z. So polar form or modulus amplitude form means r of cos theta plus I sin theta. Next, r equals to under root of x square plus y square is called the modulus or absolute of the complex number z. So r is said as modulus or absolute of z and is denoted by r equals to modulus of z, that equals to modulus of x plus iy. So two parallel lines means that is called modulus. So in that parallel line we are writing z. The angle theta is called the amplitude or argument of z. and is denoted by theta, that equals to amplitude z or argument of z. So theta is called amplitude of z or argument of z. From 192 we get cos theta equals to x by r, that equals to x by under root of x square plus y square. Consider it as a 3. Sin theta equals to y by r, that equals to y by under root of x square plus y square, and consider it as equation 4. The value of theta which satisfies both 3 and 4 and which is such that minus pi is less than or equals to theta is less than or equals to pi is called the principal value of the argument. Principal value of argument of z. If z equals to x plus iy, where x and y are real numbers, then argument of z equals to tan inverse of y by x is always the principal value, and it depends on the quadrant in which the point x comma y lies. If cos theta is positive and sin theta is positive, then theta lies in first quadrant. If cos theta is negative and sin theta is positive, then theta lies in the second quadrant. If cos theta is negative and sin theta is negative, then theta lies in the third quadrant. If cos theta is positive and sin theta is negative, then theta lies in the fourth quadrant. To find the amplitude of a given complex number, the following table may be used. See, observe the table. Cos theta and sin theta are positive, then theta equals to alpha equals to tan inverse of y by x. If cos theta is positive and sin theta is negative, then theta equals to minus alpha, that equals to minus tan inverse of y by x. This table is given in your textbook also. Cos theta is negative and sin theta is positive, then theta equals to pi minus alpha, that equals to pi minus tan inverse of y by x. Cos theta is negative and sin theta is negative, then amplitude theta equals to minus pi plus alpha, that equals to minus pi plus tan inverse of y by x. So if you observe the last column, that is first two is theta equals to alpha, and second one is theta equals to minus alpha, and third one is theta equals to pi minus alpha, and fourth one is minus pi plus alpha. First and second are, if you observe, only sign is the different, and third and fourth, if you observe, here also only sign is the different. So if you remember the first and third, then we can need not to remember the second and fourth, because they are opposite to first and third. If you remember four conditions, then it is happy. Properties of modulus of a complex number. For any three complex numbers, z1, z2, z3, first z bar equals to modulus of z bar equals to modulus of z. Second one, modulus of z1 into z2 equals to modulus of z1 into modulus of z2. Third, modulus of z1 by z2 equals to modulus of z1 by modulus of z2. So z2 is not equals to 0. Next, fourth one, modulus of z1 plus z2 is less than or equals to modulus of z1 plus modulus of z2. Fifth point, modulus of z1 minus z2 is greater than or equals to z1 minus modulus of z1 minus modulus of z2. Properties of amplitude of a complex number. For any complex numbers z1, z2, first one, argument of z equals to minus argument of z bar. Second one, argument of z1 into z2 equals to argument of z1 plus argument of z2. Third one, argument of z1 by z2 equals to argument of z1 by argument of z2. Problem 1, first problem. See, the problems are very easy, very simple. And in this chapter, we have only few formulas or few rules or few properties. If we remember that properties or that rules or formulas, we can easily find the problems. That means we can easily solve the questions. Solution. Here, the question is in the form of a fraction. First, to remove the denominator, that means the denominator in the form of complex number. So from that, if you want to convert the real number, we have to multiply and divide with the denominator's conjugate number. So here, see the solution. First write the given question, that is 1 plus I by 1 minus I. Then in the next step, we are multiplying and divide with 1 plus I to the numerator and denominator. This 1 plus I is the conjugate of the denominator. So after multiplying, we have in the numerator 1 plus I whole square. That means it is in the form of a plus b whole square. So we can expand it as a square plus b square plus 2ab by, here in the denominator we have two factors, that is in the form of a plus b into a minus b. You can write it as a square minus b square. So 1 into 1, 1 square minus I square. So in the numerator, I square means minus 1. So plus 1 minus 1 get cancelled. In numerator we have 2i. And come to the denominator, I square means minus 1. Minus of minus 1 is plus 1. 1 plus 1 is 2. So in the denominator we have 2. The numerator also we have 2. So 2 get cancelled. After cancellation we have only I. Let I equals to r of cos theta plus I sin theta. Then r of cos theta equals to 0. Consider it as a equation 1. Because real parts are equal. So here left side, the I means real part is 0. And after equating imaginary parts, we get r into sin theta equals to 1. Here we are equating imaginary parts and consider it as a equation 2. Next, add the equation 1, that is 1 means squaring, after we have to add. So square the equation 1 and square the equation 2. That means square the left side terms and add, and equal, put equal symbol and square the right side and add. That means we are adding left side terms to the one side and right side terms to the one side. So squaring and adding. Here we are squaring the equation 1 and equation 2, and then we are adding. So after that we get r square equals to 1, because cos square theta plus sin square theta is 1. So r square into 1 equals to 1. Then r equals to 1. That is modulus is 1. Next, tan theta equals to infinitive. That implies theta equals to pi by 2. That is amplitude is pi by 2. Next question, second problem. Express root 3 minus I in modulus amplitude form. Let root 3 minus I equals to r of cos theta plus I sin theta. Then root 3 equals to r of cos theta, and consider it as a equation 1. Here we are equated real parts, and if we equate the imaginary parts we get minus 1 equals to r sin theta, and consider it as a equation 2. Then r equals to, we know, under root of x square plus y square. So we get 2. 3 square means 9, and 1 square means 1. Sorry, here not 3 square, that is root 3 whole square. So root is missed here. So we have to put the root to the root 3. So root 3 whole square plus 1 square. Square root get cancelled. That means 3. 3 plus 1, 4. Root 4 means 2. So next, cos theta equals to, we can write root 3 by r. R means 2. And sin theta equals to minus 1 by 2. Consider it as equation 3. The value theta minus pi is less than or equals to theta is less than or equals to pi satisfies in equation 3 is minus pi by 6. So modulus amplitude form is for root 3 minus I equals to 2 of, that is r value. Cos theta means minus pi by 6 plus I sin of minus pi by 6. So this is in the form of modulus and amplitude for root 3 minus I. So to get the modulus amplitude form, first we have to find r value, and after that we have to write cos theta and sin theta, and which theta is satisfies for both cos and sin we have to decide. So it can easily, we can decide, or we have to follow the table rule. Already we discussed in the table 4 conditions are there. So first consider both are positive, and then you find the theta or alpha. Then you follow the table, and based on table you know which is satisfies the both. See, suppose cos and sin are positive, then we write pi by 6, and that means both are plus. And from the table, if first one is plus and second one is minus, that means theta equals to minus alpha. So here alpha is pi by 6 means, so from the second row of the table we can say theta equals to minus pi by 6. So from table also we can decide, or by simple observation from cos and sine, if we apply the theta, if it satisfies for the both, then we can look directly. So here we have two ways. Either you go from table, or you can think with your mind, which means trial and error. Like first took the positive angle and substitute in both cos and sine. If it satisfies, okay. Otherwise took negative, like that we have to trial. And most of the problems are, if we observe, there are simple values and we can easily know the theta, which satisfies the both. So if you are facing difficulty, or if you are not judging the by simple observation, then you go for table. Okay, next, third problem. Find the conjugate of 3 minus 4i by 2i. Now 3 minus 4i by 2i, that equals to, here the solution is took what is given, and in the denominator we have I. To remove that I, we are multiplying with I to the numerator and denominator. So there is no change if we multiply to the numerator and denominator. And next, in the numerator we have I of 3 minus 4i by 2 into I square, means in the denominator minus 1, so minus 2. The minus is, if we apply it to the numerator, then it becomes 4i minus 3. So then we can write I of 4i minus 3 by 2. Next, if we multiply with 1 by 2, sorry, I by 2, which are in in bracketed terms. So if we multiply with I by 2 to the terms of the terms in bracket, so look here, I by 2 into 4i means 4i square by 2, and minus into 3i by 2. Here by 2 is not printed or not typed. Next, I square value is minus 1, so 4 into minus 1 minus 4, and 4 by 2 means 2. So look here, minus 2 minus 3 by 2 I. Next, conjugate complex of minus 2 minus 3 by 2 I is minus 2 plus 3 by 2 I. See here in the question is asked conjugate, but question is in the form of fraction, and in that fraction denominator is in the complex number. So first, to know the conjugate, we have to convert the given question in the form of a plus ib. Then we can easily find its complex, conjugate complex. So the same way here we did first given question, we are converted in the a plus ib form, and after that we can easily know the conjugate. Conjugate means opposite sign of the imaginary part. Okay. Next, summary. We have discussed about conjugate complex numbers, modulus, amplitude or polar form of a complex number, properties of conjugate, modulus and arguments, principal value of the argument, solved problems using various properties, quiz. The modulus, amplitude or polar form of x plus iy is r of cos theta plus I sin theta. Second, conjugate of the complex number x plus iy is, so answer is B, that is x minus iy. Some questions are asked frequently, so if you do these questions also, you can get more confidence. First one, express root 3 plus I in the modulus amplitude form. Second, find the real and imaginary parts of the following. 4 plus 2i by 1 minus 2i. Assignment. First one, find the conjugate of the complex number, that is 3 plus 4i into 2 minus 3i. Here frequently asked questions and assignment both are categorized, means frequently asked means the questions are came in previous exams, and here assignment means these are also comes in exam, and you have to do this assignment for practice. If you do the assignment means you can remember the formulas, you know how to apply the formulas, you know how to use the properties. So all are involved in this assignment session. Second one, second question. Express the following in the modulus amplitude form. a minus root 3 plus I and b minus root 7 plus I into root 21. Third one, find the additive and multiplicative inverse of the following complex numbers. A 7 plus 24I and b 9 by 2 plus I root 5. See, the assignments are assignment questions are available in textbook also. In the textbook, exercise problems are given, so from textbook also exercise problems you can do. That is your work also, because write first in the running notes and fare it in the fair notes. So from the exercise, each and every problem you have to do and write neatly in the fair notes. So this is the today's what we learned. So once again we recall. First, conjugate complex number. So conjugate means just we have to change the sign of the imaginary part, that is. And modulus amplitude or polar form means very important. This is x plus iy we can write or we can express as a r of cos theta plus I sin theta. So this form is called polar form or modulus amplitude form. So on these topics we did some problems. So before going the problems, first we have to observe how the question is given. The question is given in the Cartesian form, that is x plus iy or a plus ib, then we can easily find its polar form or conjugate of the complex number. If it is not in the Cartesian form or a plus ib form or x plus iy form, then we have to convert it in the form of Cartesian by rationalizing with denominator, so conjugate, or simplify whatever the given question. We have to simplify. How we will simplify? If it is in the fraction and the fraction in the denominator is complex, then we have to convert it into the real number by rationalizing. So already we did. So this should be in your mind. First we have to convert it into complex form or Cartesian form or a plus ib form. Then whatever he asks, whatever the question is there, we can get easily. So if you catch this point, then the problems are all becomes very easy. This is the technique only. And two three formulas or two three properties we have to remember, otherwise we cannot solve the question, or what the question in the question what he is asking we may not get. So first we have to learn and write in a paper better what are the properties, what are the rules, what are the formulas we learned. So if you prepared or if you wrote wrote on a paper, that is better. If you have any doubt on doing the problem, then you can see which you are written on paper, then you will get clarified your doubts, or you know which formula you can use. So see the example problems also. In the textbook also there are so many given example problems. And one more thing, open the PPT in another device and open the video in secondary and in another device. If in a video screen clarity is not clear, then if you see the PPT, you can overcome the screen clarity problem, because PPT is very clear, only PPT. In the video PPT, you may sometimes it is not clear, because in video we don't know why the screen is clarity is not clear. Sometimes weather effect or technical issues are there. So to overcome this, better PPT is open in another device and see the video of the PPT in another device. Then you can easily overcome the issue of screen clarity. And next, whatever the you have getting doubts, you can ask me and clarify your doubts. You can mail me. So have a nice day. Thank you.